Hello there, my name is Isaac Lemonis, your application specialist here at R. Brown Inc.
R. Brown Inc. is a full-service ag dealer and manure equipment manufacturer in northeastern Wisconsin. As the industry rapidly grows and changes, our focus remains the same. You, our customers. We specialize in innovative and technological advances within the manure industry and are committed to improving equipment to make your job easier. This is exactly what we are doing with our newest advancement, the R. Brown Inc. pipeline system. The pipeline system improves how we handle liquid waste. It is applicator friendly and completely customizable to meet your demands. We handle everything from system design to complete installation to final pressure testing with excellent industry partners to help us in areas we do not specialize in. Our system consists of high density polyethylene or HDPE pipe, which for more than 4 decades has proven itself in the natural gas pipeline industry, where a leak-proof and safe system is crucial. It is also a proven performer above ground, on the surface, below ground, or even underwater. These attributes make HDPE pipe the perfect solution for a leak-proof, durable, and versatile liquid waste transfer system. Some of the features and benefits of the pipeline system include the ability to pump slurry under growing crops, where you want it and when you want it, minimizing fuel requirements for pumping and minimizing manure trucking costs. Combine our pipeline system with one of our booster pumps, hose reels, and or manure applicators to complete your new application system. R. Brown Inc.'s equipment is second to none in the industry with superior quality and service. All you have to do is ask.
Thanks again to R. Brown. It's my honor to introduce our first speaker, Dr. Mahmoud Sharara. He is an assistant professor in the Department of Biological and Agricultural Engineering at North Carolina State University. He received his master's and PhD in agricultural and biological engineering from the University of Arkansas with the support of the University of Arkansas Doctoral Academy Fellowship. He was a postdoc and an assistant scientist in the Biosystems Engineering Department here at UW-Madison in the Wisconsin Energy Institute. His research focuses on investigating pathways for sustainable management of agricultural waste and byproducts to generate value-added products and reduce agricultural-related impacts on ecosystems. His research incorporates the use of field studies, processing modeling techniques, technological economic assessments, life cycle assessments, and spatial optimization tools to guide the development and adoption of sustainable waste management practices and techniques. So with no further waiting, we'll let Dr. Sharara present on pelletizing manure solids. Take it away.
Thank you, Chelsea. Hello, everybody. Happy to be talking to you again. I'm, as you've probably learned, I was in Wisconsin, Madison, and UW for 2-3 years before coming down here to NC State. And happy to talk to you about pelletizing manure solids. Please, as I'm going along, any comments or any questions, don't hesitate, put it in the chat. I'd like to be as useful as possible with this talk. My goal today is basically to orient the group a little bit on pelletizing manure solids. Some are familiar with it. You see it in shelves occasionally. Some are considering it. Some already have a system or contributing to a processing facility. So we're coming at it from different perspectives. I'll share with you a little bit an outline of manure management. How do we get from manure management to the pelletization of manure solids? A little bit of why we process manures, and then why we start to consider densifying manures beyond just the conventional processing. After that, we'll talk a little bit about the different flavors, if you will, of the technology, what equipments that you can use to pelletize manure solids, what you need to consider in the quality of the manure pellets that are being generated, both in the production and in the distribution. Finally, some economics considerations for manure pelletization and some concluding remarks. So I'd like to first start with this. Many of you have seen it before, but I'd like to start with this basically to tell you that not all manures are created equal. After working with swine, with the dairy quite a bit in Wisconsin and coming down here in swine country and poultry in North Carolina, you see quite a bit of variability and difference in management. The picture you see in front of you shows you every species and whether it's a slurry or semi-solid or solid in the case of poultry. So just the differences between species automatically dictate how we house them and how we manage their manures. So as you might imagine, slurry either gets diluted all the way, semi-solid can be treated as dry. So a little bit of what you see typically, I mean, a storage pond or lagoons. This is a storage pond and the difference is significant, but for the time being, this is typically, you see it on dairy operations, more of compost piles, in-house composting for poultry litter, that's bedding, manures, and feathers. A little bit on the complete liquid management. This is a swine lagoon, typical here in North Carolina, and the solid concentration here in the top liquid is less than 1% solids. So we're talking almost entirely liquid. And finally, if we're talking beef and feedlots, then we're talking about a solid as well. So from that perspective, we start to talk about the manure management piece of that puzzle, right? To plan how we use manure sampling and analysis is critical. Many of us are familiar with the balancing act we play with nitrogen, potassium, and phosphorus in manures. This is a summary of a lot of samples, essentially a summary of a lot of studies that looked into total nitrogen and ammonium. The difference is significant. Some ammonium nitrogen that's available that can mineralize right away. Organic nitrogen, in the other hand, it's a credit. It's slow release fertilizer. And that's one of the challenges as we're facing nitrogen management. Then we start to move towards the nitrogen phosphorus ratio. That's something that is familiar to a lot of us working with manures, specifically with dairy systems. We have more of the phosphorus than we know what to do with. So that dictates a little bit of what we do. And as you can see here, species to species, that's different. Poultry is managed solids, so you get quite a bit of nitrogen and phosphorus, as opposed to some of the liquid manures that are slightly lower on phosphorus, like swine. So with that understanding, and we know that we're analyzing before land application as we agitate and haul, then we start to think about the value of manure as a fertilizer. That's the second. If the first rule is not all manures are created equal, the value of manures is not equal. And it depends, like we always like to say, how many acres do you have available to grow crops, what type of cropping rotation that you are working with, what's the soil type, essentially what is the yield expectations you're looking at, and how much phosphorus, how much other nutrients that might constrict how much you apply. We're looking also at climate conditions. That's becoming more and more of an issue we're facing, both in the Midwest and the Southeastern United States. We're looking also on what are the ratios of manures, nutrients, and forms. And as you've seen in the previous plot, there's quite a bit of variability. And we know that quite a bit. Even as we're agitating a storage pond, we get a variability between one truckload and the other too. So sampling is the key to get a critical handle on the amount of manures. And finally, the big one is manure volume. Notice that I highlighted the manure volume and the acreage available because it all boils down to it. Supply and demand. If there's more of one than the acreage, then the values start to diminish fast. And finally, what's the application cost? And I want to go back a little bit to the piece about climate. Many of us, and as I talk to colleagues across the US, we're starting to see that in the top picture, you see these are fields that are either it's a wet fall and winter or wet spring. It becomes a challenge to go into fields to prepare the fields, let alone apply manures. So that we're seeing the windows are tightening quite a bit, let alone in the lower picture when a hurricane or extreme weather event comes through, then the entire storage structure becomes in peril. So we need to start thinking critically about not just the value of fertilizer, but how to make sure that it doesn't become a net negative for a lot of folk. When we look into it, and this is sort of a part of a big study that looked into the cropping systems across the United States and the relation between cropping and manures. So looking at continental US, you get to see kind of every county in the US and the predominant crops growing there. You get to see easily the soybean and corn in the Midwest, a little bit of wheat in the plains, and a little bit here down east with hay and wheats. What this map doesn't show you, aside from the crops, is the yields. And that's one of the biggest things that I've noticed coming down here. Corn yields, soybean yields are significantly lower, different soils, not the Midwestern soils, which means that an acre, a unit land ability to remove nutrients is significantly diminished because of that. So that's another piece when we are doing the balance of manure and crop balance. we're reiterating that point again. So we're either applying nitrogen-based or phosphorus-based. Phosphorus-based is the typical approach we're typically using in the Midwest. A little bit different down here. It's a nitrogen-based applications, and you get to see how that impacts soils. You see if you are applying on a nitrogen basis, you end up applying a little bit of that surplus phosphorus beyond what the crop needs, a little bit of extra phosphate as well. Potash or potassium, I'm sorry. As you are managing it on a phosphorus basis, as we should, then we find ourselves having to supplement nitrogen and potash to get to what the plant removal or what the crop maintenance needs. And when we manage using one over the other in base, which happens in a lot of places around the country, we start to see some issues, especially in the hot or intensive production pockets of the country. This plot here map gives you a kind of a county by county breakdown of the phosphorus generation. And we're focusing on the phosphorus because that becomes the odd balancing element in the manure. So you get to see hog is the primary producer of phosphorus in Minnesota, Iowa. We move here to dairy and beef country. As we move southeast here, we have a very big pocket of phosphorus here from hogs and poultry, otherwise throughout the entire southeast. So that gives you sort of an idea of the tonnage that each county is generating. And as a result of the balance between the crop and the soil, we start to see maps like this, which tells you which counties in the country can act as a sink and which ones act as a source of phosphorus. So on the left here, you see the dark brown. Those are the counties with a big surplus of phosphorus. As you get into a lighter brown, then there is a surplus that can be managed within the county if we actually did manure transfers or transport programs. And as you go to the green, these are the areas where the actual removal exceeds the generation. So as we'll start to look at it, you can immediately recognize there are certain pockets around the country, including in Wisconsin, where we see there is a benefit to actually redistribute the manures a little better. And when that accumulation start to happen, we start to see really negative headlines. A lot of these adverse impacts start playing out. So we start to see something like algae growths in lakes, especially in the temperate lakes. We're talking Lake Erie. That's one of the biggest issue that keeps cropping up every summer. And the role of animal ag or dairy production in Ohio is becoming more and more scrutinized. As we move closer to the Wisconsin production, we see both the phosphorus and the nitrate in the groundwater is a big concern related to agriculture and animal agriculture in general. Some outbreaks and recalls related to E. coli, especially from cattle and dairies out west. We're talking Arizona, California, and so on. And down here in North Carolina, litigations on lawsuits over swine production have been significant, with millions of dollars in awards, with smell is the biggest source of strife between communities and between producers. So that sort of gives you an idea of when we talk about manure accumulation, it's not just we're looking at a map, would like to make the map all balanced. It's actually because of a lot of these impacts start to play out. So as a result, we start to look into our toolkit as engineers and technicians into what do we need to put in the farm to actually kind of mitigate these impacts. One of the most versatile and most attractive pieces of technology right now is anaerobic digesters. We're breaking down the organics and making energy, fuels, and RNG or natural gas, and that's quite a bit of interest to a lot of folk. Solid liquid separation, this is more towards the nutrients. We're kind of creating a high nitrogen product and more of a one-to-one nitrogen phosphorus product in the solids that can allow us more flexibility. Composting is another product in basically biological but aerobic, unlike the digester. And finally, drying. So this is sort of a quick scan. We see more of the first two, digesters and separators, more so than composters and dryers on dairy operations, mainly because we're targeting improving the nutrient ratios. We get more management flexibility. Solids can be stacked, stored, potentially distributed and trucked longer distance. We're talking about biogas, greenhouse gas reduction. has a value, a monetary value, and has an environmental value. So that's one of those win-win. Odor control, again, that's one of the bigger issues, especially when you have the production of animal systems and animal farms are coming closer to communities. I don't anticipate that's happening as much in a lot of the Midwest, more so down here in the Southeast with population growth and urbanization is becoming a concern to a lot of animal producers. Also, the nutrient loss reduction, as we're becoming better in controlling the composition of the manures, we're less likely to lose it. Also, the bacterial count. If you are recycling bedding, then measures to control the bacterial count is one of the critical concerns that you'll have to manage. And finally, as I indicated, the amount of the volumes, the cubic feet or thousands of gallons that you have on site in a very wet year become very, very valuable. So that's why we process manure, but why do we densify manures? And that gets us to certain very high density production areas of manures. That's where you actually need to move the manures more than just down the road, a mile or 5. We're actually talking longer distance, potentially transporting over rail. So that becomes a challenge if you are transporting something that is only 20 to 30% solids. Becomes a challenge to a hazard for road. It becomes, you're essentially moving water, which can become very uneconomical very quickly, and an odor and a nuisance hazard as well. Also, feeding, loading, and unloading, it goes without saying, making granules or pellets makes it much easier to feed and handle. Long-term stability too, if it's produced with a low moisture, enough moisture content to prevent mold and bacterial growth, then it can maintain its structural integrity for a very long time. You can also have a better control over nutrient profile, because at this point you can actually mix organics and minerals, some potash, some magnesium, sulfur, whatever the soil or the crops you're targeting, or potentially if you are after an organic certification, you can actually composite more than just the manure. So we kind of know that with manures, we are locked around the 1-to-1, about 3 to 5% nitrogen, about 3 to 5% phosphorus. If we want to increase one over the other, we're forced to look into other sources. We're looking into bone meal, feather, and so on. A lot of these products that becomes very challenging to land apply bulk that you actually have to process, and granules is one of those options. Also, we're talking about precision for land application, calibration of spreaders for just separated solids is important, but there's only so much efficiency you can achieve. How long the solids have stacked can affect the profile or the spread patterns for the solids. Finally, we don't see that as much with dairy, more so with beef and with poultry litter that has higher carbon content, that these pellets can just go beyond land application. You can actually gear it towards a co-firing if it get pelletized along with wood chips or bark and so on. So that sort of gives you an idea of the points where we start to actually think beyond just the solid liquid separators, a DAF or a screw press. When we start to talk about this technology of densifying solids, there's so many ways we can do it from engineering. We can essentially keep agitating that material and in order to form these balls or these granules, basically, is what we refer to. And typically we have to rely on the assistance of something, a binding agent or an adhesive material. Alternatively, we can rely on a compaction, essentially high force and pressure and extrusion process. Either we compress them or we extrude them through a die to shape them length and diameter of interest. Potentially, we can layer the material as well, or over layers of as it's being sprayed, it dries, and you end up with these molecules. So the first one gives us the granules, those spherical shapes that we're familiar with. Extrusion gives us the pellet, those cylindrical shapes. Those can be modified later, and we'll talk about it briefly, but it doesn't need to be that cylindrical unique shape. And for globalization, we find ourselves with prills, which essentially we see that more with urea, with a lot of the mineral fertilizers, but some operations that we've toured and looked at, they're using prilling to make compost pellets as well. So if we focused on the first two, primarily the agitation and balling, this is a common shape that we all are familiar with, or many of us are familiar with. If we looked into fertilizer operation, some feed processing, this is a pen granulator and a drum granulator. And the principle here is simple. As you can see here on the right, this is basically the operation, a rotating desk that keeps moving the material upwards and it slides by gravity. You see here on the right-hand side, the larger particles slide down.
No problem.
And the smaller particles are still up top. And we are spraying here the adhesive or the binders. Similarly, drum configuration that accomplishes the same thing. Alternatively, we can do fluidized bed or a mixer granulator. We can also put a pin mixer ahead of that system. So there's so many flavors where we can do that as a one-step, two-step. One thing you can notice here is that this system does not really favor material with fiber. So as we start to talk about manure solids, especially dairy manure solids, we start to have high fiber and low fiber. So a screw press or potentially a screen can be a good strategy to hold the larger fiber and then the finer solids that are either DAF'd or centrifuged. Then these solids, after we can stack them dry, or we can use a dryer system and then start using a pen granulator. So that fiber piece is critical to consider. Also, the density of the finished product. Typically, we're talking around 30 to 35 pounds per cubic foot. Sometimes even lower, slightly lower than 30. And notice that because we're not compressing this material, it doesn't end up being as dense as we'd like. So it's still, and the particles, depending on what's the mean diameter, and we'll talk a little bit about diameters moving forward. As we go to our larger granules, the density of a truck, you can only hold a much smaller amount. So that's sort of, we start talking about the balance of those two as we move along. The other family of technologies, we start to talk about extrusion. Extrusion, essentially, as you can see here, an auger, feed zone, compression zone. Typically, we rely on heat. Heated augers sometimes help us ensure that the material is compressed sufficiently. It doesn't need to be very wet or very dry, somewhere in the interim. And we rely also on a die for the extrusion. You can kind of see for very long pellets here. And it could be either a flat die with rotating, with rollers, or a ring die, essentially, that extrudes out the pellets on that round die. But this is kind of the different technologies. Here, that material or that extrusion technology has been in use for a while with the wood waste to create wood pellets for co-firing or for combustion. So this technology is already recognized and practiced for high fiber material. So as we're thinking about, so down here, if I'm working with swine solids, swine does not consume any fiber. So these manures are ready for extrusion with granules. And I can use an extrusion system like this as well. But for high fiber material, probably we're going to be moving closer to an extrusion system like that one. As we start thinking about the process, binders come into play, especially if we are forming granules. And that's what we see in a lot of the commercial products already being distributed. A lot of the types of binders, either we add a matrix binder, which we add in bulk amounts that essentially blends almost in 1-to-1 or 3-4 manure to 1 of that binder, starch and beeswax and all of that material paraffins can bind the granules as we are forming manure solid granules. Alternatively, water, alginates, lignosulfonates, a lot of these materials are used much smaller amounts. All they do is form a small coating or a film around the material to essentially help the particles adhere to one another to form kind of a seed, and that's it. So we use it in much smaller amounts. And as you're looking through these, be cognizant of a lot of the differences between what's mineral or and what can be certified as organic. That's one of the priorities for a lot of producers right now trying to enter the organic market. a lot of the consumer demand is swinging towards interest in organic products and products produced using organic fertilizers. So it becomes very important to think about, would you be interested in this market, and what is the characteristics of the manure you're working with and how to get it to a fertilizer quality with organic certification. As we talk about the pellet and what's the quality of the pellets, particle size is one of the first thing we start to think about. Generally speaking, we know that the granules, no matter how hard you try, you'll never make them as uniform as you'd like to be. Working with fertilizer, we all understand that. There is a distribution, basically, a range. Lower end, higher end. Typically, we do a D50, which is basically what's the sieve size that holds 50% of the granules or particles that you have in your material. An SGN gives you an idea of the average size of your pellets or granules in millimeter multiplied by 100. And we're familiar with the ranges between, 80 around the smaller end, closer to 200 or above, essentially 2 millimeter in diameter or above. Those numbers are valuable, especially for turf, for golf courses, and a lot of these niche markets that can pay a premium for an organic soil product. And that's, as you'll see, a lot of the producers looking towards pelletizing and granulation look for that market because it's a high value market compared to the bulk market of crop or field cropping use. Also, GSI, that gives you an idea of the spread of particle sizes, or the uniformity index as well, UI. The last one is that should be a UI, not a second GSI. Apologies for that. But all of these are sort of metrics to keep in mind when you are characterizing what are the markets that you are targeting need, and how to essentially go back and engineer the process to give you the particle size. Another important piece is the durability. We kind of touched on the distribution and the fact that granules and pellets, generally speaking, are loaded, unloaded multiple times, probably put in super sacks or bagged and stored. All of that is mechanical stresses on the material. And unless we have a good handle on the durability of that material, that can become a very poor product. It will not have an uptake, and essentially will be stuck with a technology system on the farm with no takers. So the durability of the granules is very critical. And that's PDI is basically a durability index. That's a tester essentially rotating a drum with a certain mass of granules and getting to see what's the percentage that is still intact that can stay on the sieve after. And we target for as high as possible. 90% or above is a good number to shoot for a lot of these. A lot of producers with products are, claiming higher than 95, 98, and so on too. So it's important to know what are the competing products in that space. Hardness is another one of those variables that we look into. How resistant is the individual particle or pellet to fracture? And we see that slightly less in this manure granulated markets and more in feed particles, which doesn't really relate as strongly here, but gives you sort of an idea of how is it going to be applied, what the equipment, and you have to actually develop these recommendations. So quickly, as we, beyond just the technical and the mechanics of the process, as we start to talk about manure pelletizing, we have to keep in mind what are the state regs when it comes to that product. Oftentimes, we're not going to granulate and pelletize to turn around and apply on the same farm or maybe down the street. That does not make economic sense. Oftentimes, we are doing a wide distribution. So as you bag and distribute and put a label, you have to be careful what you can call a product like this. Is it an amendment or a fertilizer? Every state has its own specific language relating to what soil amendment means, what fertilizer. The uniformity batch to batch is very critical. And we famously have a challenge with that with manures. Just the seasonality, the climate, how it affects the nitrogen nutrient profile, just operation uniformity can affect that. So as we're trying to enter the fertilizer markets, it becomes critical to have quality control in the system we're putting together and be aware of what the regs are. Also transparency, and a lot of the times the perception issues, if you do not disclose what are exactly the ingredients that can become a source of suspicion by consumers. So in a lot of the examples that I'll share with you, you see a complete disclosure if it's the blood meal, if there's feather, if there's swine manure or poultry manure. It's very important to indicate that along with what are the microbial counts. Also, the odor, one of the bigger challenges we're seeing here for acceptability for poultry pellets and granules, primarily because of the strong urea odor, is making it difficult for poultry granules and pellets to enter the golf courses and landscaping and some home gardening to a degree. So that's something also to be cognizant of in producing some of these materials. Obviously, along with the educational information, not just this is a bag of granulated manure or fertilizer, but what is the recommended use? If there are trial data compared to kind of commercial fertilizers, along with what are the recommended rates for gardening, for golf courses, what equipment to use. Also, we're talking about targeted markets, and a lot of the work and the reports that and the companies that produce a lot of these products start to target specific either nurseries, solid producers, as I indicated, landscapers, golf courses, either also state and city governments for a lot of the road work that they do. They are occasionally in certain areas can be a large consumer of these products. So that's also something to keep in mind in the market research. Finally, the distribution and markets. Basically, after you study the intended consumers along with what is the educational material and what they need in their products, do you prepare one or multiple blends and brands? Do you essentially allow other big box stores to actually take that material and put their brands on it? Or basically, are you entering bulk market versus household? So all of these are very important to be conscious in planning a pelletization operation for the manures. And we see quite a bit of successful systems like this. I pulled an example here for a product and pulled from its label specifically the guaranteed analysis. As you can see here in the label, it's a 5% nitrogen, 3% P2O5, and 3% K2O. And along it lists calcium and magnesium and sulfur. It also specifically said what it's derived from and tells you what else is. So they added bacillus and some microbial beneficial microbes for biological activity in the soil, and they indicate specifically the count for each gram. So it's important to look into this, and more producers actively turn around and add microbial colonies to essentially enhance the breakdown of these granules. I'll briefly kind of breeze through a couple of full-scale composting and granulation operations that I've seen down here specifically, and kind of to share with you a little bit of an idea. These are kind of an idea of swine lagoons here in North Carolina. As I indicated, it's primarily liquid that most of the producers are managing, but at the bottom there's a long legacy of sludge that has to be managed. Think about 10 to 20 years of sludge residue. That's high phosphorus, that's high zinc and copper. And when it comes time to remove it, they rely on is adding a polymer and bagging into large geotextile bags and dewatering. These bags, we're talking hundreds of tons, oftentimes depending on the size of the swine production complex. So imagine the amount of solids that you have overnight on the facility. So for a lot of producers, that's a big bottleneck here. And for compliance, that's one of the biggest areas we're focused on here. What are the technologies that we can put on in front of producers? Some private companies coming through have actually brought together some of these solutions, including a composting, as you can see, a commercial scale composting, followed by a prilling and screening operation, essentially that creates a powdered product along with a granulated product, then turns around and gets bagged and distributed with its own label for a lot of the turf and lawn care distributors around the country. I'd like to draw your attention a little bit to what I mentioned before, the ingredients. So you can see the guaranteed analysis. It says here the ingredients are compost and biochar, 50-50, and it's derived from pine wood scraps and swine manure. It indicates exactly what are the rates or recommended applications, what equipment, belt-driven top dresser to apply a lot of this material. So what are the applications, and what the rates and frequency. So it becomes more, and I guess one of the big takeaways is, as we're talking about pelletization, we start to think about it's not just one piece of equipment that is added on the farm. That's more of a venture that is added with its own market research and a distribution network. So it is a big undertaking, but potentially lucrative if it's designed correctly. Another, and that's a little bit more information on this. We had a virtual tour, including some videos of that site and the operations there. And I put here the URL, and you'll have it with the handouts too. You can kind of go and closely and read what are the equipment, the operations, and feel free to reach out with any requests for additional info on this. Another project also attempts to do the same, but except for doing this, actually the goal is to transfer, and that's a headline, to transfer to a big fertilizer plant in Florida. So take it and that solids or that sludge material to a site that actually have access to urea and mineral fertilizer to create the profile. So the product you see over there, that's a 16 nitrogen, 3 phosphorus, and 0 potassium. We cannot get these ratios with manures alone. So that's a mixture of mineral and organic. And in this technology here, the process, the material goes to a facility with a lot of other residues, conditioned, cooked at high pressure and high temperature. And then that's where the other mineral nutrients and salts are added, goes to a granulator, and then the granules are dried afterwards, screened to select for the size, coated, and then bagged and distributed. The fines from the screens go back for processing. So that looks very promising, and they've already processed and created a large profile of products, more than 98% solids, and in different packaging. But the challenge has been that sludge, to get it from the swine operations to where you have a fertilizer company that is interested. That's a distance, that's a logistics. And it has been a barrier so far. And in some of the research we're working with, both entities were trying to see what are the engineering solutions that we can put in place to kind of close that gap. Because we're not just adding a technology on a farm, we're bringing together two industries that do two different things. So a little bit of the work that we've done on the dairy systems of trying to answer some of these questions of, do we get a benefit from centralizing a pelletization? Essentially, instead of doing a one farm, we kind of pool farms together to one site to pelletize. Do we have difference county to county or region to region? And if so, what are the key drivers in the process that we need to kind of improve and optimize? So in this particular study, we pulled a similar process that uses a paddle mixer, pin mixer, and then a granulator, a dryer, screen, and then a granule product. Collected the data on the capital, what type of polymer, the amount of energy required for drying, electricity, obviously, to operate all of this, labor for a plant, and the transportation. Because bear in mind, we'll actually have to aggregate manures from different sites into that point. And that's kind of an idea of the pilot that we've done in FICO in Wisconsin. And pulling the data of where dairy operations are in two different parts in Wisconsin, where the locations, how many lactating cows and getting, and sort of a closer idea of the amount of manures based on the milk production as a proxy for the amount of organics coming in the manures. Based on that, turning around and building getting a sense of the distribution of the sizes of herds, one over the other. Obviously, you in Wisconsin understand that part, which ones contain, as we move towards the kind of around the Fox Valley, Green Bay area, larger dairies compared to more what we see close to the Madison area and so on. So you get to see that the distances between farms and the sizes of the farms are different, even within one state like Wisconsin. So as we model this, we started to put together what is the profitability of a project like that over a 20-year period, and adding a solid liquid separation, because for dairies, we need to go from however we are, 5%, 6%, all the way to ideally 20 to 30% solids. And then either do we put a separator on every farm, or do we separate the manures in one site when we granulate. And that was very interesting to kind of put that for the simulation to decide and finding out what are the outcomes. We found that every time a separator on every farm is always a good idea. And that's one of the other messages I want to leave you with, right? You cannot get to a pelletization without actually having a solid liquid separation. So some of the results that gives you an idea of when we kind of put that model together, we found that you'll probably need about 20,000 heads of lactating cows to have the capacity, the cheapest price of sale price per ton of pellets. For that pool of farms, you're probably gonna use 75% of the cows, the manures, to make these pellets. And that's about the cheapest, the best ideal place to put it. Notice it's not just about drawing a circle and everything in it. It's about the size of the farm, how much manure. Is it worth it to haul it over this distance or not? So not nearby farm is not necessarily a natural go-to to aggregate solids. Started to see that in a different region with different sizes and distribution distances, the logistics are a little different, but roughly around the same number of heads, 20,000 heads of lactating cows. One of the most interesting pieces, basically, if you take one thing is that as we open up how wide we are pulling manures from, you see the price drops very quickly per ton and then start to kind of stabilizes, evens out. Basically, if you aggregate it from 300 miles, you're not going to get better economics than probably this. You're probably not going to be logical for you to bring it that long distance. So there's that kind of almost break-even distance, and we're familiar with that for trucking or hauling manures, but even for aggregating for a project like this, there's a good break-even distance. A little bit idea of when you kind of constrict the radius, the optimal space moves. So we kind of, here, if you don't have a limitation, this is where you build your facility. A little bit, if you constrain it to 10 miles, this is where it gets built. And that's really important to kind of put a study like this in mind, because a lot of projects don't do a lot of that analysis. It starts one place, and commitment and capital raising, which is interesting and really good, but kind of plants the seed in your mind that there is an optimal way of doing this. There is a way we can actually use these tools and models to have confidence and avoid unpleasant surprises for these technologies. This is kind of an overview of how sensitive that technology to the cost of natural gas, to size of the herd, whether you get a cost share for the facility or not. And finally, this is kind of a little bit of a cost assessment of looking into, do you pelletize or granulate? And you've noticed that for pelletizer, oftentimes you don't have to buy a binder, which can be a significant cost. And you can actually have a denser material, which can be trucked longer. So that weighs into that costing as well. And I'm adding resources here if you have any questions about this. I'm sprinting through because of the time, but I really wanted to share with you a lot of that work we've been putting together. A little bit of the work, finally, and your key speaker today, Dr. Zavala, that's some of the work that we've taken that granulation, putting into that big framework. If we're trying to kind of shift the balance of the phosphorus in the right direction, where do granulation as a technology falls? So we found that always it comes after separation, and we find that it becomes more promising than, say, if you're doing struvite from a cost per unit phosphorus. So quick takeaways: manure processing is becoming more and more a requirement on farms. The more you advance processing, you get more flexibility to create value, not just to process nutrients. You can actually tap into markets, but the technology, even though it's attractive, is costly for most farms. So as we talk about technologies like this, we need to get out of the framework of one farm, one system, to more of a centralized, an investor or a developer coming in. Market analysis for these technologies are very critical, and we all understand that, and we all know technologies put in with the best intention not panning out. And finally, the cooperative model is very promising for a technology like this. And with that, I'd like to really thank you. And if there are any additional questions, I want to acknowledge the funding sources for the work I've done in Wisconsin, as well as down here on the same topic, and a little bit of the references here at the end.
Great, thank you. Any thoughts or comments on mobile pelletizers?
That's a really excellent question, and it's almost one of the intuitive pieces that we need to move into. Maybe the challenge as we talk, maybe pellet mill can be one piece, but as we talk about granulator, notice that we probably will have to have a granulator pan and then a screen, maybe a mill. So depending on the technology, certainly a mobile pelletizer will do a great job. Depending also on what is existing infrastructure on the farm. So absolutely, it's one of the better ways to kind of lower the barrier to do this. Reducing the cost of systems. Both are really, we're pointing in the same direction. If any solid liquid separation systems on the farm, that really helps. We're talking as we find cheaper ways to do this, or on the other hand, find ways to upvalue this. So there are certain nutrient trading markets that we can tap into. So not just kind of like what we do with biogas. We're not just tapping into the value of that as a fuel. We're actually getting an offset from renewable credits, right? So certain areas where there are nutrient trading schemes, you can actually collect more than one credit. So that becomes the reverse way of actually putting the full value of a technology like this. I see a question on additional work on solid animal manures beyond separated dairy. Absolutely. So we are looking into more poultry, and poultry actually is more in the commercial space before any of the separated, because it's readily dry. So already our colleagues up in the Delmarva area in Delaware and in Maryland are composting and pelletizing this product. And there are state supports for the distribution or some credit schemes that they can take advantage of to help these technologies, but it's already there. Steer, that's interesting. Honestly, I do not know of a steer manure specifically. It becomes critical to think of it of the scale. How much the amount that we have available, and what is that a centralized entity that will do this, or the producers themselves would take that on themselves. So there are you see niche products here and there, but becomes it's difficult. It's not one of the main ones that we are familiar with: the poultry, the dairy, or more recently the swine. The combustion value for the pellets, that's a very important question. So it depends on how much would sawdust. Basically, especially when we talk about whether it's a feedlot manures, so we're typically talking in the range of around 14 to 16 megajoules per kilogram dry. I don't know for a lot of us on the call that these units don't make a whole lot, but for us in the fuel space, that is kind of more relatable. How much woody materials are there makes a big difference. We're seeing that with a lot of broiler and poultry producers here, because there's a big market in Europe for wood chips. That means that the sawdust and a lot of the woody biomasses that were readily available or not, that means that the litter stays in the houses longer. It breaks down more, so the energy, we don't get as much energy. We get more nitrogen to carbon that we want. So there are a lot of moving pieces when we get to the combustion piece, and it stops and starts and stops, whether it's up in the Midwest or down here southeast. So that's a piece that I didn't emphasize for that reason. Depending on the air permitting and regs, can really be a big unknown in that process.
All right, great. Thank you again. And thanks again to Arbron for their sponsorship.